Ladies and gentlemen, good morning to you from not only just outside of Chicago, but also from Germany near the Danish border. We got a very interesting guest, a fun guest on the podcast today, Klaus Harder from Freecon. Now, you might think about Freecon and their involvement in the wind industry. Just as a little teaser of what we're going to be talking about today, they are the manufacturers of the 20 Newton meter ultracapacitor module that replaces the batteries and charger cards out in the field in a lot of the GE turbines. But they do a ton more in the wind space. They have a lot of things that are now developing into the future growth of the wind space. I want to introduce you to Klaus Harder, Business Development Manager for Freecon. Klaus, thanks for coming on the podcast.
Thanks for having me. Great to be on the podcast here today with you. Thanks, Dan.
I have to say, Klaus, I don't think we've ever had somebody outside of the United States, the 50 states, come onto the podcast. So welcome as our first international guest, hopefully the first of many, but no pressure being the first one, Klaus.
All right. Yes, I feel honored to be the first German participant in your podcast there, Dan. That's great.
Absolutely. And I will say, Klaus, I didn't even tell you this off air. I told my grandmother, who's from Germany, that we were having a German representative on the podcast today. She's very excited to tune in. I don't know if she's very interested in the ultracapacitor technology, but who knows? So this one's for Grandma, and then we're going to dive right into it, Klaus.
Very good. She might get interested in ultracapacitors after this.
Hey, that's what we're here to do. So, Klaus, there's a lot of buzz in the industry about ultracapacitors, Freecon, the development of all these different products and applications to hopefully continue to refine the efficiencies of the pitch system. Before we get into any of that, first I'd like to start with you. In looking at your LinkedIn and understanding your background, it's very extensive in the wind space. NEG Micon, Vestas, Repower Systems, Lagerwey Wind, and now you're at Freecon. Could you walk us through your background, maybe education, your evolution of career within the wind space, and then ultimately how you ended up at Freecon?
Yes, sure. As you mentioned already, Dan, I am from the very north of Germany, and literally I grew up on a farm which was directly at the border to Denmark. So standing in the yard, I could look over the border to Denmark. And I remember when I was 15 years old, that was back in 1980. Right on the other side of the border, they started, like the Danish, as you know, they were the first country really to go seriously into wind energy in the late 70s, early 80s. And I could watch out over the border, and they were installing a wind farm over there. That was back in 1980. Each wind turbine had 50 kilowatt of power, very small compared to today's turbines. But I was fascinated right away. Like Germany at the time was mainly run by nuclear power and coal power stations. There was no wind energy at all. So I drove over on my bicycle to the Danish side, have a look at these wind turbines, and I was fascinated. Those Vestas wind turbines, 50 kilowatt. And I made a decision there, and then I want to work in renewable energy in the future. So that's really how it started. And then a few years later, I moved to Denmark, and I made an application in Denmark at the Danish Center for Renewable Energy. I got a bit sidetracked there because they also did research in biogas, anaerobic digestion systems, and because I had a farming background, I was also fascinated by this technology. So I worked mainly then in anaerobic digestion for a couple of years, coming back to Germany, doing projects over here in that field. But then after a couple of years, I made the move into wind energy. And that was back in 1997. I started in Energy Micon, which was one of the major Danish manufacturers back then, and they were looking for technical staff here for their German subsidiary. So that's how I got into wind energy. Basically, that was the start, really. Then,
What was it about the early wind turbines that you saw over the Danish side of where you were living in Germany, looking out over the border? What was it that drew you to the wind turbines itself?
I think it was a kind of an aesthetical thing to see these rotors spinning in the wind, and in the evening when the sun was going down in the west, you could see these wind turbines turning and producing clean energy. So I thought it was a great concept, and I thought the wind turbine itself was a fascinating machine. And of course the whole background of, back then in the late 70s, there was in Germany, they were building nuclear power plants, and there was a lot of protests against it and a lot of discussions, about the future of our energy system. And the narrative was, Germany is a big industrial country. We need nuclear energy. There's no other way to power this country. And over on the other side of the border in Denmark, they decided, we want to look into green energy, and we don't want to install any nuclear power plants at all. So that was also part of the story, really, that fascinated me,
Absolutely. And I think that's really neat that you were able to see. I think that's basically the origin story of the modern day turbine, is the 70s in Denmark. And then you have these big companies come out of Denmark, obviously Vestas being one of them. And looking at your background, you're now at Freecon. The turbines are still complex. They're still evolving, ever changing. Could you maybe talk about how Freecon is playing a role in the evolution of the wind turbine? Maybe just talk about a general overview of the company.
Yes, that's a very good point there, Dan. Like, Freecon really started out back in the late 1980s when Norbert Henschen, the founder of the company, started developing the first power converter for a variable speed wind turbine. Those were the early days of power electronics, where you could have AC/DC, DC/AC conversion in a higher power scale, like 100 kilowatt, for example. So he started developing the first power converters, frequency converters, in those days when the first turbines of 50 kilowatt, 100 kilowatt were developed. At that time, it wasn't, all the other turbines were fixed speed. There was no power converter. The efficiency was low. And the power converters were quite expensive because power electronics were so expensive at the time. But to make a long story short, Norbert, he could see the potential for power electronics in the wind industry, and started developing these power converters at a very early stage. And then obviously, as the turbines became bigger and bigger, and at the same time power electronics became cheaper and cheaper, then suddenly it started to make sense to use large-scale power conversion and develop variable speed wind turbines. That was really the beginning of Freecon back then.
What was the first product that you had actually put out, or Freecon, I should say, had put out into the marketplace? And then maybe similar to your background in the evolution of your career, could you walk us through some of the steps of that first product to now what we actually have in the field today?
Yeah, maybe before I talk a little bit more about Freecon, I go to the second part of your question. First, like my personal journey in the wind industry, after working with Energy Micon and Vestas, I then started working for a company called Repower, which later became Senvion. And that was back in 2005. And one of the tasks I was doing there was product improvement of the Repower 6M offshore wind turbine. And that was a very interesting time, because that was the beginning of professional offshore wind farms in Germany. And Repower actually was the first company to develop a wind turbine specifically for the offshore industry, for offshore application. And that taught me a lot about components in wind turbines, and also about the importance of reliability of these components. Because if you have a turbine out there in the sea and a small component fails and the turbine stops, the costs are immense, to get the turbine up and running again. Maybe it's stormy, you have to send someone out with a helicopter to get this service team over. And I mean, a small, like talking about pitch systems, like the battery failing in the pitch system. The battery is maybe $150, but to get it replaced out there, that could be $15,000, if you have to send a team by helicopter, and you're losing a lot of money, So that kind of, gave me a lot of insight into reliability issues of components, and how important it is that these turbines are developed in a proper way, and that the right components are used in the system, So that's maybe just to give you a bit more background on my journey in the wind industry. And that maybe leads us to the next question you asked about Freecon's products. And one of the projects Freecon did in an early stage, that was around 2000, was to develop the complete electrical drivetrain for the Goldwind 1.5 megawatt turbine, which Goldwind, as most people know, is now one of the top 5 players in the market in the wind industry. And we developed the pitch system and the power converter and the control system for this turbine. And that basically was the first time that ultracapacitors were used then for the pitch backup system. So far, there was either electrical systems with batteries out there, or it was hydraulic pitch systems, like Vestas was using hydraulic pitch systems. And that was the same philosophy. The components have to be reliable. You want to minimize downtime of the turbine. And we could see the problems with hydraulic systems, leakages, and different service issues in the field. And we could also see the problems with battery systems. So we developed this ultracapacitor pitch system together with Maxwell back then, which then really became a huge success, and other manufacturers followed actually to use this technology then.
It is a perfect segue. You really set this up nicely for me here, Klaus, to talk about, before we proceed forward, the battery. So what is this battery that we have out in the field? A lot of the technicians and engineers listening into the podcast already know, likely in the United States, are using, if you have a GE15 or even a 2X platform, those Enersys batteries, lead acid batteries that are a part of the emergency pitch system backup system. Could you maybe tell us what the difference is between your traditional lead acid battery and then what the ultracapacitor actually is in the framework of the GE pitch system? So just contrasting the two.
Okay. Yes. as you said, most people listening into the podcast probably have some kind of background, and I suppose to keep it fairly simple, on the one hand, you have a lead acid battery, which is the standard solution. If you buy a GE wind turbine, it's a lead acid battery there in the pitch backup system. And of course, those batteries have their advantages, and at the same time they have their disadvantages. I suppose the main advantage is that they're cheap to buy. It's a standard component, and they're built millions of times. And I suppose talking about the disadvantages, it's mainly the limited lifetime of these batteries, just because they are lead acid batteries, and they work in quite a harsh environment up there in the hub of the turbines. So you have to replace them every 4 years regularly, and often you see them failing even earlier than that. So you have to replace them even before 4 years are gone. Simply because of their I suppose temperature is the main issue. Cold climates never really help a battery growing very old. That's probably one of the main issues, and the general chemical decline you have in the lead acid battery with the electrolyte. So it is a service issue. And then on the other hand, the ultracapacitors, they actually, they don't have an electrochemical charging process. You don't have an electrolyte. It's an electrostatic charging, and that means there's no real degradation going on. You can charge them 1 million times, and they still be fine. So an ultracapacitor can last for 20 years, and you can charge them, as I said, up to 1 million times, no problem at all. And also the ultracapacitors, they don't have a problem with cold temperatures. They work in minus 30 Celsius just as well as in plus 40 Celsius. So the whole idea is, yes, to have a reliable energy storage unit in the pitch system, and you minimize downtime and you minimize service visits. That's really the whole concept.
I know many of technicians out in the field that would love to not have to replace batteries, especially when it's freezing cold out in South Dakota, minus 10 Fahrenheit, having to go up tower into the hub and replace the batteries every couple of years. It could be a large challenge, not just from like a cost of goods standpoint, but also a safety component as well. Going out in the hub is never a task that you could take lightly, having to climb down the nose cone, kick open the hatch and drop in. So I think there's a lot of different elements of the ultracapacitor that solves challenges out in the field. Another thing I'd like to just touch on is the battery charger cards and the relationship between the UCAP and the charger cards. Does the ultracapacitor need the charger cards? Does the customer then allowed to get rid of the charger cards along with the battery? Because those can also be costly and quite pesky in terms of their failure rates.
Yes, I come to that in a minute. But just before we go into that, with the chargers, you mentioned the safety issue there regarding climbing into the turbine, climbing into the hub in the winter time, and there's always a certain risk associated with it, I suppose, and it's not a great job to do, really, especially if it's freezing cold and maybe stormy. Another, just before we forget about it, just to mention, another safety issue is actually with the ultracaps, you don't have the problem of maybe gases coming out of the unit. We know in certain circumstances you can have a problem with batteries in the hub if they're overcharged, if the charger is not working correctly and there's overcharging, that gases can evaporate from the battery, which can also lead basically to an explosion if you then have electric sparks happening. So this is not often, but it is a risk. It's something that can happen. You're in an enclosed space, and you could have a problem like that, which then really would be a serious danger to the service technician. And that's also the nice thing about ultracapacitors. This cannot happen with an ultracap, and also you can discharge them to 0 volts. You can't really do that with a battery. So if you need to work on the system for some reason, you can always discharge the system completely down to 0 volts, so you have no risk of sparks or anything at all. So it's just another safety issue and an advantage of the ultracapacitors. I think that's worth mentioning.
Yeah, absolutely. And I'm glad that you touched on that. And I also want to reiterate the point too. This is 20 plus years of life you had mentioned to the battery, maybe averaging 4 years, in some cases less, in some cases maybe a little bit more. And then also we touched on, and I apologize for overlooking the safety aspect, because that is absolutely critical and very important for sites to consider. We also talked about the charger cards, and there's obviously a cost involved in those, typically much more expensive than the batteries. And they are prone to failures. So maybe talk about the 20 Newton meter ultracapacitor, how it's retrofit, and then also the role of the charger cards, or the lack thereof charger cards.
Yes. So yeah, that's a very important point, I think, because what we have seen in the field with the standard GE pitch system, that one of the reasons for the service visits, of course, is the batteries themselves. But another reason also is failure of the charger cards. And seemingly, they're quite sensitive to voltage fluctuations or power quality issues, maybe, and quite regularly that they have to be exchanged. So that's another reason then for downtime and for additional service visits, and finally loss of revenue, really, in the wind farm. So the ultracapacitor pitched retrofit solution, that's coming with its own charger solution. So we replace both the batteries and the chargers, and the ultracapacitor modules have their own charger, which we have developed, and which actually is a very robust charger, is very robust when it comes to voltage fluctuations or any power quality issues. And so basically we solve two problems with one retrofit. We solve the problem of the batteries failing, and we solve the problem of the charger cards failing. That's basically the idea here.
Yeah, I think it's fantastic. I've been able to work with sites that have the 20 Newton meter ultracapacitors installed. And just as a sneak peek, there is a 30 Newton meter product in development, and I definitely want to talk to you about that. But one of the big advantages that I hear is you no longer have 4 separate batteries and charger cards. The 20 Newton meter ultracapacitor module is just a drop-in replacement. You pull those 4 chargers, charger cards, and batteries out. It's one module. What is it, 50 pounds roughly, that's mounted in the hub to replace the 4 components, and then you set it and forget it. I think we should talk maybe about SCADA. Does it interact with SCADA? Is there maybe updates they have to make to their system, these different customers that are installing the 20 Newton meter ultracapacitor, or does SCADA read it the same as a battery?
Exactly, as you said, then it's a front-end solution. That's what we call it, and that also goes for the SCADA. So it has the same interface that you connect, and the SCADA can read it the same as it would read the battery system. So there's no changes really you have to make on that side. So it's really designed as a drop-in solution also from that point of view. You know?
Yeah, very good. Now, I think there's probably going to be a lot of questions about Freecon and then also Maxwell. In the past, Maxwell was at least providing these units here in the North American market, especially the United States. And you guys had a former relationship, and I think there can be some confusion of, well, who's producing what? Is Maxwell the original producer of the equipment? What is Freecon's role? Could we maybe just talk about that and you touch on the former relationships, the evolution of the product, and now how you guys are bringing this to the wind market here in the States?
Yes, we can speak about that briefly, of course. Our cooperation with Maxwell goes back a very long time, back to when we started developing systems for Goldwind and other manufacturers in the Asian market 20 years ago. And that's also when basically around 2014, 2015, we were approached by big wind farm operators if we could develop such a retrofit solution for existing turbines. So we developed that together with Maxwell. As I said, that goes back to 2014, I think, the start of the retrofit solution development. And that was a cooperation between Maxwell and Freecon, where basically Freecon would do the development and the manufacturing of the units, and Maxwell would do the marketing and the sales of the units. That was the agreement there. And that went quite well for a couple of years. But really it changed then in 2019 when Tesla bought Maxwell and the focus changed within the company. And basically there was no longer interest to focus on the wind energy market and pitch retrofit products. And that's when we decided to market the system ourselves and look for partners in different parts of the world to sell this system to wind farm operators. And that's really how I think our cooperation also with you guys in Kurz started, when we were looking for distribution partners for this system. So that's kind of the background. The system we sell today is the same system that we developed with Maxwell kind of 5 years ago. And that's really how it all got started,
Yeah, and that's really fascinating too. And you mentioned Tesla, which I think is pretty interesting, the involvement of Tesla and Elon Musk in working with Maxwell, obviously with the acquisition and everything else. I think it's a testament to the technology that both you and Maxwell together were producing and the different applications that it can service. We've talked a lot about the GE pitch system, the retrofit system. We've talked about the 20 Newton meter ultracapacitor module. I think we should get into the 30 Newton meter ultracapacitor modules here in a little bit, but I'd be remiss if we didn't bring up some of the other applications or at least turbine types that you do service. So we've talked about GE. Are there other applications? You also mentioned OEM with Goldwind that you guys can service with this technology.
Well, when it comes to pitch retrofit products, we could offer a system for any battery pitch system out there in the field, and any wind turbine type that has a battery pitch backup system today, we could convert that to ultracapacitors. I suppose the reason that we started with GE, that's where the requests came from. That's where there was an active interest from customers. And also, of course, there's large volume of GE turbines out there in the field, probably, I don't know, 25, 30,000 turbines. If you combine the 1.5 and 2.5 megawatt platform, it must be more than 30,000 turbines today, I'd say. So that's why we started focusing on the GE turbines first. But yeah, we're looking into other manufacturers as well. Like we have quite some interest now from operators of cellular turbines. They have a similar system, battery system in the pitch. So yeah, that's probably the next product we're going to release later this year, would be a pitch backup system with ultracapacitors for cellular turbines, starting with the 2 megawatt platform, but also then later rolling out to the 3 megawatt platform. And then it depends a little bit on where is the most interest from the market. As you know, there's other manufacturers, other turbine types out there with battery pitch, and we're looking into the whole market, but it really depends where's the most interest, where's the most potential, and the volume to make it interesting for us, you know?
Right. And you talk about interest and volume. I can't tell you a time when I've gone to a GE2X site, a 30 Newton meter site, that hasn't at least asked, well, hey, you guys are the ultracapacitor company, or at least represent the ultracapacitor company. Do you guys have a solution for the 30 Newton meter towers, these bigger blades? Could you talk about maybe the most recent product development that you guys have brought to market, this 30 Newton meter ultracapacitor module? Maybe talk about the differences between the 20 and then also the challenges that have come with the development of this product, because it is a different application. Instead of 4 batteries and chargers, it's 6 batteries and charger cards. The blades are much larger, heavier. So I can imagine it was quite a challenge to develop this product and now get it out in the field.
Yeah, the 30 Newton meter product, that's a new product that we've just been releasing now, and we're starting with the first test installations in the field. And as you said already, the 30 Newton meter looks quite different to the 20 Newton meter system. The 20 Newton meter is basically one box per blade that you drop in and you replace the battery box. With the 30 Newton meter, you have 6 individual modules that you replace, and each module has its own charger card on it. So it looks quite different, but of course the principles are just the same as with the 20 Newton meter. The advantages are just the same. So it's more a physical difference there, just from the way the 30 Newton meter hub is designed. So yeah, we actually have developed this new product, 30 Newton meter, for the larger GE turbines, and we're just in the process now of rolling out a few pilots, trying to get some experience in the field with the system, and then later in the summer we want to start the serial production of these units and roll them out on a larger scale.
I'm very excited about it. Obviously, I think a lot of the sites out there too with larger blades experiencing battery issues are likely excited. I still want to dig a little bit deeper in terms of the product design differences, and with that 20 Newton meter module just being a box, but then you have these module designs. So one ultracapacitor module for the 30 Newton meter towers replaces the battery and charger card. Was there a reason in particular that you decided to create individual modules instead of one large box that's a drop-in replacement?
Well, it's basically just because, again, to make it as comfortable as possible to do the retrofit in the field, and basically because of the 6 batteries, it's and it's a larger system, it wouldn't really work as a one box solution. It would be too heavy, it would be too big, and would also require some technical modifications. I think that could be a bit tricky in the field. So again, the background and the idea was to have a drop-in solution that can easily be handled and wouldn't require too much modifications in the field. And that was kind of the main idea behind it, that we said, okay, let's go with 6 modules that can be easily inserted there and wouldn't require too much field modification. That was the main idea behind it.
I think it's fantastic too. You have to formulate the product with a technician in mind, especially if they're doing the installations. Sometimes you can hear out in the field, well, why the heck did, such and such OEM make it so I have to shimmy down in between these two, metal pieces? I got the gearbox over me trying to change out this part. So I love the technician focus that you've brought with everything that you guys have been doing. I think we should maybe talk about too, this ultracapacitor is not just a concept, especially the 20 Newton meter. You guys have brought it to market, and there's quite a few turbines retrofit, not only with the 20 Newton meter ultracapacitor, but also the other ultracapacitor technologies that you rolled out to different turbine types. How many ultracapacitors are actually out in the field today of your Freecon ultracapacitors?
Well, the Freecon ultracapacitors, it depends a little bit on how you count it. Like we developed the Goldwind system with the ultracapacitor pitch, and we manufactured the first prototypes ourselves for Goldwind. And then basically we sold the license to them, technology license, so they can manufacture themselves in China. So they, like the 1.5 and the 2.5 megawatt platform Kurz turbines, that's over 20,000 turbines in the field, and that's all based on the Freecon design. But obviously we didn't manufacture those Ultracap modules ourselves. They were manufactured by Goldwind then in their own factory, but they're based on the Freecon design. And there's 7 or 8 other OEMs in Asia that we then later helped to manufacture their own modules. So that's on the OEM side, where we mainly did development, design, prototyping, and then selling the technology. If we talk about the retrofit solutions, then we're talking about roughly 1,000 turbines in the field now, GE turbines that have the retrofit installed, and there's a smaller number of clipper turbines. I can't remember exactly, it could be 70 or 80 clipper turbines out in the field that also have an ultracapacitor pitch retrofit that we developed for the customer.
1,000, and definitely growing too. Definitely,
Yes.
definitely a few have already shipped out of our Kurz location to some customers.
Yes.
So I think that market is going to, or at least that turbine number is going to continuously increase as we roll out this product.
Yeah, that's great. That's great. Good to see it.
It's a great overview, Klaus, of the ultracapacitor technology, batteries versus ultracapacitors, future developments of different products, the 30 Newton meter GE ultracapacitor that is starting to be piloted now. What we like to do on this podcast is do a little rapid fire round to wrap it up. So I've got a list of questions here. You could take as long as you want to answer them, but some are related to wind. Others are not so much related to wind and more personal, because I think it's important for people to get to know you too on a personal level. Obviously, we've got a great relationship and longstanding relationship, and I hope to share that with the audience. So I don't know if you're ready for the rapid fire round, but here's question 1, Klaus.
Okay, go ahead, please.
What do you like most about wind? We'll start out with a softball here. What about the wind industry do you like the most? I mean, you talked about being young, seeing the turbines being developed in the 70s, across the border in Denmark, but I guess more recently, what gets you most excited about the industry?
Yeah, I suppose it's two aspects. One, of course, is the technical side of it, the technology. I find it fascinating, all the different components that work together and make the wind turbine a successful machine. But I suppose the other thing that I like about wind energy is that it really can contribute in such a great way to decarbonize our energy consumption. And we all know this is hugely important, and especially over the next few years will be a big issue. And I think, yeah, wind energy together with solar and energy storage is really a big part of the solution there. And I find that fascinating, you know.
I couldn't agree more. And I guess this is a good dovetail into the next question of, you're obviously passionate about the wind space. You've been passionate for a very long time, starting at a very young age, which I've found is rare in the industry. But once people get in, they get the bug, they never want to leave, and they just become obsessed. I'm one of those people who came from a totally different, unrelated industry, and now I'm going to be a windcateer for life. So outside of passion, which I think is probably the most critical, important aspect of being successful in wind, what do you attribute most to your success in the industry, working for a lot of these large OEMs and companies that are producing new innovative technologies? What do you attribute your success to the most without being able to say passion?
Well, that's a very good question, Dan. I would say for me, it's beside the technology again. It's a lot about people. You know, I'm a team player. I like to work with people. I like to work in a team. I like to learn from people that know more than me, and there's a lot out there that know a lot more than I do. So in all those years in the wind industry, I think my success is basically based on team effort and working in a good team and maybe motivating others to give their best. A lot of the times I've been a team leader and with the different OEMs, team leaders of different groups. So I think the team effort and just working together as a group and supporting each other, I think that's one of the main keys to success, I think.
I would agree. And to add on to it as well, I think the culture of the wind industry as a whole is so strong and tight knit. We're still in our infancy, even though there's been a lot of technological developments recently, especially we're hitting that growth curve. Offshore is starting to get brought here to the United States, which gets me very excited. But I have noticed it doesn't matter what site you go to. It seems that they welcome you with open arms, and everyone's on the same page of servicing the industry, continuing to push the industry forward, and putting their best effort into that team collaborative aspect that you just talked about in pushing wind and renewables and this new the decarbonization of our global climate and energy production to light. So I could not agree more with you, Klaus. One of the questions that was asked to me by a fellow teammate of mine was talking about the differences of the wind industry. While the culture may remain the same globally, I think different markets have different, I guess, illustrations of the wind space in them. So for instance, here in the United States, we're big into self-performing. You see a lot of GE Investis machines. Have you seen any differences, or can you point out any differences between, say, the United States wind market versus the European wind market, which might be a little bit more mature than the United States, and then also other global markets with wind as a power generation portion of, you know, their energy production?
Yeah, I mean, for example, here in Germany, a lot of the wind farms, and I think that's a big difference maybe to the US, a lot of the wind farms are actually cooperatives. So the local people have a chance to buy shares in the wind farm, and that, of course, helps with the acceptance of having a wind farm installed maybe a few fields away from your house, you know. I suppose in the US, it's a completely different story. Of course, you have much more space than we have in Europe in most places. And you can install large wind farms. Big cooperatives can invest huge money installing huge wind farms, which is great and necessary to drive the energy transition, of course. But in Europe, space is a big issue. We don't have that much space where there's not many houses around or small villages or whatever. So that's probably one of the main differences. You have all that space. You have a huge, vast country, and you can install turbines, thousands and thousands. Nobody can see them.
Yep.
Over here, that's a bit different, and that's probably also the reason why for the last few years there has been a strong drive towards offshore wind. Of course, that's then you don't have this problem of local acceptance of the wind farm. If you're out there in the sea, you have space again, and you can install wind farms without bothering anybody, really. So that was probably one of the main drivers to go offshore here in Europe, kind of 10 years ago. And today, I suppose, almost close to half of the new capacity that we're going to install over the next few years will be offshore compared to onshore, really. So that's a big difference, I suppose, compared to the US market, for example.
Yeah, that's a great point that you bring up too, and I've overlooked that quite often, is the amount of offshore wind in Europe and the different challenges that comes and brings to the wind space. I actually want to touch on maintenance, and I don't know how much you know about this, but how does maintenances differ from an offshore wind turbine versus an onshore? I mean, earlier you said helicopter, which that's brand new to me. I've never considered that a helicopter could be used to bring technicians out to these offshore wind turbines, but I guess other ways too, that the maintenance is or taking care of these towers differs from onshore to offshore.
Absolutely. I think the focus is much more on preventive maintenance and really planning your maintenance schedules, having some spare parts on the turbine already, just in case, and trying to minimize transport, trying to minimize service visits. Like on an onshore wind farm, if you send a technician to an onshore wind farm, he drives maybe 50 miles with his van, and then he hasn't the right part on the van. He comes back the next day or a few hours later. That's not really a big deal. It doesn't really matter, you know. But if you don't have the right tools or the right parts with you on an offshore wind turbine, then it costs you $10,000, you know, because you have to go back, you have to come back the next day, and it's just so much more expensive. No matter if you go on a helicopter, of course, helicopter is the most expensive mode of transport, but also with the boat, if you go out with the boat for 2 hours and you have to pay for the boat operator or whatever, it costs you $5,000 minimum each trip, you know. So the focus is much more on preventive maintenance and trying to optimize really the service activities in the wind farm to reduce the costs, actually.
Yeah, reduce downtime and all of that. I think we could maybe compare it to like crane costs for onshore winds. Bringing out a crane can be quite costly, and if you have inclement weather or you have to keep the cranes on site overnight, a lot of that downtime you're having to pay for it. It sounds similar too with offshore, with your boats or your helicopters. It cannot be cheap to transport somebody out there, and especially if the seas are choppy, you're in a boat that's rocking back and forth and all over the place, and you're having to climb onto the platform and get into the tower. I can imagine you want to be 100% dialed in, knowing exactly what the problem is, it being able to resolve it. So I feel like those guys on offshore have to be excellent troubleshooters just right out the gate.
And I suppose another aspect is also that the whole safety issue becomes even more prominent. I mean, today in onshore wind, there is already quite a high awareness, I think, around safety and climbing up the tower and all the things that can go wrong. But with offshore, that is heightened 10 times. You know, you have much more risk. You have the water, and if something happens out there, it can be so much more difficult to bring him back home to base. So the whole safety training and the standards are even higher, and there's much more focus on working safely, you know.
Yeah, it's a fantastic point that you bring up. And I really appreciate you talking about offshore and you being able to work with that and share some of that insight to us here in the States, because we don't have a ton of it yet. But it looks like the new administration is rolling out a push to, I think, double or triple offshore wind capacity by 2030. So I think it will become more of a commonplace to see these offshore wind farms getting put up in the United States. So it'll be fun to watch those developments and see how that market shapes. Now, Klaus, I've got three more questions for you and we'll wrap up the podcast. These ones are a little bit more personal.
Right.
This first question, I will admit that I personally wanted to know this. This is like my favorite question outside of talking about the ultracapacitors to ask you. Being from Germany, where would you tell one to go? Were they to go visit Germany for the first time? And do you have any particular cuisine or maybe beer recommendations?
Okay. Yeah, that's well, I suppose it depends on what kind of person you are and what you want to see. If you like the nature, I suppose you have the choice between the mountains and the sea. If you want to see the mountains, you go to the south of Germany, Bavaria, breathtaking scenery. I suppose maybe a little bit similar, maybe not really, but like the Rocky Mountains, you know, high mountains, and you can hike and climb and whatever you like. So for mountain people, the south of Germany, of course, is the choice of destination. If you're more a water person, if you like surfing or going on a boat or whatever, then obviously the north of Germany, where you have the North Sea and the Baltic Sea and the beaches, and then that's the place. That's where I'm from, and of course, I personally would recommend come to the north. You know, go to the sea. And I suppose if people are more into culture and cities, there's probably Berlin is probably the first place that comes to mind, you know, very multicultural and lots of culture and music and theater and whatever you like. So yeah, but I personally, if you ask me, I recommend northern Germany, Danish border, come to the sea.
Very good. I'll book my ticket.
And your next question, of course, the favorite beer up here is called the Flensburger beer. Flensburg is a little town. They have a brewery that's probably been around for 300 years or so. I was brought up on the Flensburger beer. So I highly recommend to taste that, yeah.
The Flensburger. Okay, I'll have to get that from you after this episode.
I'll make sure you get a few bottles over to the office there.
I'll hold you to that. Definitely. I'll have to do a taste testing maybe this Friday evening.
Yes.
And then I guess in the cuisine side. So my dad, you know, I've talked about to you offline a little bit how I've got German grandparents, and my dad loved when my grandmother would make a meal called Schweinehaxen. Now I might be butchering the name.
No, that's pretty accurate.
It's about I don't know, 8-10. I mean, it looks like it's 15 pounds on a platter of just meat, you know, fatty, rich meat. Is that the go-to cuisine for you personally, or would you steer somebody into a different direction were they to go to Germany, do, I guess, like a food or an eats tour?
That's a good question, Dan. Like, I mean, my mother, she's still alive. She's 86 now. She would make some old recipes that kind of a mix between Danish and Northern German cuisine. I probably don't have the English words to describe them because they're quite particular with plums and meat and things you normally wouldn't mix, you know.
Yeah.
But even those recipes, they're hard to find today in restaurants or hotels, you know, because they're almost old forgotten recipes that not many chefs would still be using, I suppose. So I recommend, if you're in the area, I said you should come to the north of Germany. I'd say come to visit me, and I'll ask my mother to make us a nice meal, and that should be an adventure, you know.
That is the nicest offer we've ever had on the Kurz Wind Podcast, Klaus. Personally inviting
Thank
guests
you.
out to your place in Germany. That's amazing. That's great. So I guess we'll get a caravan together and just fly on out. Be ready for us.
Yes, I'll be ready for you.
No, it's a great answer, and I appreciate you filled in that particular question, especially for me. Two more questions for you. One was a popular favorite with some of the people that I reached out to prior to this podcast. Talking about the Autobahn. What's the fastest you've ever driven on the Autobahn?
The fastest, I'm not really a fast driver, Dan. Like my cars never have gone very fast. I suppose the fastest was a friend of mine. He got a new motorbike. That's years ago, 30 years ago. That was a Kawasaki Z900. I only had a Yamaha 400. He had a Kawasaki Z900, and he allowed me to take it out for a ride. And so I probably went around 200 kilometers an hour. What's that? 120 miles an hour on the motorway, but only for half a minute, really. I got frightened then, and I slowed down again, you know. But it was, that was a bit of an adventure, all right, you know. But otherwise, I wouldn't be the fastest driver really on the motorway. I'd rather go slow and safe, you know.
No, absolutely. But I think it's crazy. Roughly 120 miles per hour, 200 kilometers an hour on a motorcycle.
Yes.
That's very, I mean, our speed limits out here in the States, at least in my state of Illinois, it's about 55 to 65 miles per hour. So that's basically snail's pace compared to the Autobahn, or going as quickly as you did on the motorcycle. That's crazy.
Yeah, I mean, today it's even crazier, you know, with all these new 300 horsepower motorcycles on the motorway. Even if you go 100 miles an hour, someone behind you, you know, wants to push you off the road, you know. Today it's really crazy, and I don't enjoy it, you know. It's too crazy on the German motorway, you know.
I would honestly agree with you on that. That sounds getting past, and you're going 100 miles per hour, being the slow one on the motorway.
Exactly.
It's an experience that I think everybody needs to have at least once, but maybe just once is the most.
Just once is enough, really, you know.
So
Yes.
Klaus, it's been an awesome podcast. This is the last question I typically ask everyone. Put you on the spot here again, and then we'll wrap it up. It's, if you were to be able to put a slogan, a mantra, or a saying on a billboard that everyone in the world could see, so obviously a hypothetical here, what would you put on that billboard?
Wow, that's that's a slogan or a mantra on a billboard. I've never thought about that, Dan. Nobody ever offered me that opportunity.
Good, it's a curveball.
Yeah. Maybe take it easy. Don't let the sound of your own wheels drive you crazy.
Yes. Take it easy. Don't let the sound of your wheels drive you crazy. Any reason in particular you chose that?
No, it just came to my mind. I probably could think of better ones later on, you know.
No, I think it's fantastic. I think it's actually a message of unity, which we probably need right now, you know, globally, or at least here in the States. So take it easy. That's fantastic. We appreciate that.
Yeah. Okay. Good stuff, Dan.
So Klaus, this has been episode 16 of the Kurz Wind Podcast, obviously with Freecon. What a great episode. We really appreciate you coming on. how can people get in touch with you in particular, at least find out more about you and your company?
Well, just drop me an email, k.harder@freecon.com, and I'll be happy to answer any questions, and then share my contact details, and we can have a call if needed, whatever,
Fantastic. And we could put all the different links in the show notes. I'll probably put your LinkedIn profile in the show notes, as well as your email, your website. But Klaus, again, I just want to thank you so much for taking out over an hour of your time today to come on to the 16th episode of the Kurz Wind Podcast. It's been a really fun conversation, and I hope we can do this again in the future.
Good stuff, Dan. I really enjoyed it. It was a pleasure.
Yes, absolutely. Really appreciate you, Klaus. Again, this is episode 16 of the Kurz Wind Podcast. We're signing off.